from Department of Mathematics, Kailash Mix College, Nangavalli. Today I am going to explain about the topic is differential equations. In differential equation, we have two types. One is ordinary differential equation, another one is partial differential equation. Today, let us see what is ordinary differential equation and its types. Okay. So, first of all, what is ordinary differential equation has four basic definitions. First definition is order, second one is linearity, third one is initial conditions, and fourth one is how to form a differential equations solution. Okay, in linear we have three types. One is first order ordinary differential equation, second one is second order ordinary differential equations, and the third type is nth order ordinary differential equation. Linearity has two types. One is ordinary linearity, second one is partial linearity. Initial condition has also two types. One is feasible solution, another one is basic solution. So next, we have to form a classified ordinary differential equation based on only order, linearity, solutions. These three conditions only we have, then only we have to form a ordinary differential equations. So next one is how to classify the solution methods. Next we are going to see derivatives. In derivatives, we have two types. One is ordinary derivatives, another one is partial derivatives. In ordinary derivatives, we use the notation D because D denotes differential equations. So that we have to use in ordinary derivatives, the notation is dy by dx. In partial derivatives, we have to derivative only partial variable. So that's why here we have to use dou u divided by dou y. This is the notation of ordinary derivatives and partial derivatives. So ordinary derivatives in y is a function of one independent variable because y is a function of one independent variable. Partial derivative in the sense u is the function of more than one independent variable. In ordinary derivative, function depends only one independent variable. In partial derivatives, function depends one or more independent variable. Next, in partial differential equation, the some basic example is dou square u by dou y square minus dou square u by dou x square is equal to 0. Already I told in ordinary differential equation, ordinary derivatives are one or more independent variable. Here also in partial derivatives involve one or more partial derivatives of unknown functions. So this is the difference of ordinary differential equation and partial differential equation. Now we go to the next topic is we are going to see ordinary differential equations definitions. So ordinary differential equation involve one or more ordinary derivatives of unknown functions with respect to one independent variable. So here I will give some basic examples. First example is dy by dx minus y is equal to e power x. Next, the second example is d square y by dx square minus 5 into dy by dx plus 2y equal to cos x. In this second example, here I already told one independent variable only in this ordinary differential equation. So here y of x is an unknown function and x is an independent variable. So one independent variable in unknown function is called ordinary differential equation. Next, order of a differential equation. First we told what is ordinary differential equation. Now let us see what is the order of a ordinary differential equations. First of all, I will tell you what is the definition of order. The order of an ordinary differential equation is the order of the highest order derivative. For example, dy by dx minus y equal to e power x. Here y is the one unknown function and x is the one independent variable. So here we have the derivative 1. The order is also 1. So this is the example for first order ordinary differential equation. Next example is d square y by dx square minus 5 into dy by dx plus 2y equal to cos x. Here the order is 2. So this equation is called second order ordinary differential equations. So next one is d square y by dx square the whole cube minus dy by dx plus 2y power 4 is equal to 1. This equation is also called second order partial differential equations. This cube is not considered by the multiplication, so that this equation is also called ODE. Next one is how to form a solution of differential equations. So first I explain what is the solution. So here a solution to a differential equation is a function that satisfies the equation is called a solution. Okay. So first example, dx of t divided by dt plus x of t equal to 0. Now how to prove that differential equation? Let us see. First we have to take x of t equal to e power minus t. First we have to take the initial value x of t equal to e power minus t. The proof is dx of t divided by dt is equal to minus e power minus t. So first we have to differentiate x of t but once. Then only we get e power minus t is the derivative of minus e power minus t. So the equation is already here. Dx of t equal dt plus x of t equal to x of t value, first time derivative value is minus e power minus t. So we have to substitute in the place of dx of t divided by dt. The answer is minus e power minus t. Plus already I will take x of t value is e power minus t. So we have to add these two, we get 0. So 0 is the solution of this differential equations. Next, linear order differential equation. First we have to say what is linear order differential equation. An ordinary differential equation is a linear if the unknown function and its derivatives appear to the power 1. This is called linear ordinary differential equation. So no product of unknown function and or its derivatives does not apply. In multiplication, power only derivatives that may be 1, 2, 3 or more at etc. nth derivative it will be available. No multiplication. So this is the example of non-linear differential equation. Here already I give you. So power is available here 2 whole cube. So that this is not a linear ordinary differential equation example. Okay. So these two are the linear ordinary differential example. So next one is already in starting I told the boundary value problem has two types. So one is initial value problem, another one is boundary value problem. In initial value problem, the auxiliary conditions are at one point of the independent variable because the independent variables are same. So this is called the initial value problem. The second one is boundary value problem. In boundary value problem, we here one point of the not at one point of the independent variable. Here we used one or more independent variable. So this is the two differences of initial value problem and boundary value problem. Here the independent variables are 0 and in boundary value problem the independent variables are 0, 2. So that is a different. Next I will tell you classifications of ODE. In ODE we have lot of classifications in different ways. Here I will give you some classifications of ODE. First one, order. In order we have three types. First order ODE, second order ODE, nth order ODE. So next one is linearity. In linearity we have two types. One is linear ODE and another one is non-linear ODE. Here also auxiliary conditions have two types. One is initial value problem and another one is boundary value problem. Next, solutions we already told. These are all the examples of ordinary differential equations. So next, how to form a linear basic equation. So linear definition is a first order differential equation is said to be linear equation. Here is the example: y dash plus p of x into y equal to g of x. Y dash denotes dy divided by dx. Here d is told the ordinary differential equation. D by dx is called the first order ordinary differential equations. So next I will tell you how to solve first order linear ordinary differential equation. Here I will give some equation: y dash plus p of x into y equal to g of x. This equation will take by the equation number 1. So the solution is, first we have to multiply this equation number 1 by mu of x. So multiplying both sides by mu of x called an integrating factor. It equation gives, here we have to replace in the place of y dash by dy by dx. So the equation gives mu of x into dy by dx plus mu of x into p of x into y equal to mu of x into g of x. Simply we multiply equation number 1 by mu of x. So this is the equation number 2. Next we have to assume mu of x into p of x is equal to mu dash of x. So this is the equation number 3. So next we have to replace equation number 3 to equation number 2. We get mu of x into dy by dx plus in this place of mu of x p of x by mu dash of x into y equal to mu of x into g of x. This is the equation number 4. So next, by product rule 4 becomes mu of x y of x whole dash is equal to mu of x into g of x. This is equation number 5. Already we know the basic condition of derivatives. So that equation is uv the whole dash is equal to uv minus vu dash. This condition is already we know, already we studied. Okay. So now in the place of uv, here we have mu of x into y of x. So the first equation is mu of x into y of x the whole dash is equal to mu of x g of x. This is the equation number 5. Next we have to simply multiply by this equation. So which implies that the equation gives mu of x y of x is equal to integral mu of x g of x dx plus c1. Here we have to add compulsory the constant term. So that only here we add c1 is the constant term of the equation number 5. Okay. So next we have to divide this equation by mu of x. We get the equation number 6. So that is y of x is equal to this term, upper term is also in fixed common. So that's why we have to write the upper term as common. So next one is, in this side mu of x is the multiplication term. So we have to replace this mu of x by that side, opposite side. We get divided by mu of x. This equation number is 6. Now we need to solve mu of x from equation number 3. Equation number 3 already we know mu of x p of x is equal to mu dash of x. In this side mu of x divided by mu dash of x divided by mu of x is equal to p of x. So next this we take p of x in the place of mu dash of x divided by mu of x is we replaced by in mu of x the whole dash. Okay, so here also we replace in this place of in mu of x the whole dash is equal to p of x. So this p of x we have to integrate. Already first we have to integrate the equation. We add one constant term c1. Here also we have to second time integration. In this side we have to add another constant term. So that term is c2. Here the solution of mu of x is equal to e power integral p dx plus c2. So therefore this is the equation of c3 e power integral p of x dx, equation number 7. So this equation is called the solution of ordinary differential equation. So in this basic of ordinary differential equation, we have to see some basic example. So next we have to see the example is, I have to summarize the solution process. So first step is put the differential equation in the form 1. So next find the integrating factor mu of x using 8. Multiply both sides by mu of x and write the left side of 1 as mu of x y of x the whole dash. Second one is, last step is integrate both sides and solve for the solution y of x. Next we have to see one example of, let I tell you the example of linear ordinary differential equation. The question is y dash minus y is equal to e power 2x. The solution, before we go to the solution, first I will write the formula of linear ODE. The formula is y of x is equal to e power minus integral p of x dx into integral over e power integral p minus integral over minus 1 into dx into integral over e power integral. In the place of p we have to replace by minus 1 into ds. In the place of g of x we have to replace by e power 2x dx plus c. Just integrate integral of minus 1 into dx we get x, because minus into minus is equal to plus, so that the integral over dx is x. So this simplified by e power x. In this we have to simplify by integral over e power minus x into e power 2x into dx plus c. We have to add these powers to we get e power 2x minus x gives e power x. So this term is simplified integral e power x into dx. We have to integrate e power x by, we get the result is also e power x. So e power x into e power x plus c. Just multiply by e power x these two terms, we get e power x into e power x. We have e power 2x plus c into e power x. So c into e power x plus e power 2x is the solution of this given linear ordinary differential equation. So this equation have for one order. So this equation is also called first order linear ordinary differential equation. Okay, thank you.